Hello and welcome to the Cavbotics programming video series. This is the first video where you will actually be doing some programming, and we're going to start off with the most simple thing you can do in all of FRC, at least from a programming perspective, which is make a motor spin. Very simple and a great way to see the foundations of everything that we do in FRC. All right, so you can see right now I'm in the main class, but I'd like to first show you how we get to this point. Now, if you followed the setup correctly, you should have the VS Code installation from WPILib installed. And if that's correct, then you will have the WPI command palette. It's this little symbol. It may look different if it's a new version of WPI, as they do change the icon, but you will have this icon in the top right. From there, you will select create a new project. If you don't see it, you can always just type create a new project and it should pop up. Once you do that, you need to select a project type. We will first take a template, then we will take one that is in Java, as that is the language that our team programs in. And we will select timed skeleton advanced. Again, if you can't see it for some reason, you can still type it. You will then, find a folder that you would select to put it in. I already have this project created, so I will not be doing that. You will give it a name, and you will put an 8590. Once you have done that, you simply generate the project, and you will get levels and levels of folders that will eventually have core files of main.java and robot.java installed. So first, I would like to have us do the two folders, two files, which is the things that we need to add to our project in order to have the complete setup for programming any FRC project. So the first is that two files part that I mentioned. The first of those files is robotcontainer.java. This is where we will do a lot of important things like mapping our bindings to the controller or setting up an auto routine, but not all of that will be done in this session. We also have constants.java as our other class, where we will keep track of any constant variables throughout our project, so we don't have to remember arbitrary numbers or booleans or strings or whatever we might be trying to keep track of. Our two folders are, as you can see here, commands and subsystems. You don't need to put anything in them right now. You just need to have them right there. And also, if at any point you're trying to find anything specific that I'm using, you can keep in mind that all of the code for all of these lessons are available on the 8590 organization on GitHub. So that's just github.com/FRC8590. Now we can actually begin and see how do we make a motor spin. So we're going to start in the subsystems, right? Because every robot in FRC is simply a robot that's broken down into subsystems, and those subsystems might be an arm or a shooter or a drive system. Those are all the components of what eventually becomes one FRC robot. Now in this case, we are just creating a subsystem that has a motor. Most subsystems in FRC will have a motor. At least on our team, they certainly will, because we have never used a solenoid. That might change in the future, but we have always done motor-based functions for everything, and that's what we're starting with. So the first thing you need to know how to do is to create a motor. And so we're using the SparkMax class from Rev Robotics, and to install that, there's a handy tool right here where you can see by pressing the symbol on the left side of your WPILib, you will be able to find RevLib and click install. You can see here I've already installed it, but say I was trying to install Advantage Kit, right? There's an install button. It's very simple to install these. You also want the WPILib new commands, and that's really all you need to do for installing dependencies. But you can definitely get used to doing that, because it will be something that you do many, many times every time you are using a new library. Moving on from there, this assumes that you know at least Java on a basic level, right? And that we are declaring these variables as private for this subsystem. And we are also having our identifier, right? We are using the SparkMax class, and we are labeling it motor1 because you will be using like sometimes 20 motors in one project. And so it's very important to keep track of them with unique names. Usually you would rather have a name like, I might say, left shooter motor, right? And that's what I'd call it. But in this case, it's a very simple project, so we're just going to call it motor1. We will then instantiate it, and we will first give it an ID in that every motor, or rather every motor controller, has an ID. Again, at Cavbotics, as of 2025, we use Neo motors and Rev Robotics SparkMaxes to control these motors. And each of these motor controllers can be configured to have a unique ID. And this is very important to have because let's say we had a left wheel that had ID 1 and we had a right wheel that also had ID 1. If we wanted just the left wheel to spin, we'd suddenly have both of them spinning. So it's very important that everything is unique and everything is different and everything is identifiable. And because we want it to be easily identifiable, that means we don't just want, say, motor ID 1 and write down 1 every time because it's going to be hard to remember. So what we have is this constants class. So if I check what motor ID is, you can see we have public final class constants. It's final because, like I said, and like the name suggests, these are all constant. They don't change. And so in this case, instead of trying to write down 1 every time the motor ID might get mentioned, we just have the label motor ID, and it will always refer to the number 1. We also have the motor type, and this will always, or should almost always, be one of two types. You're either doing motor type.kbrushed, or you're doing motor type.kbrushless. This tutorial right here is made for a brushless motor. Those are usually what we will be using. If you are using the kitbot, you might be using a sim motor, but we're not getting into that right now. We're trying to keep it simple. We are doing a brushless motor, and we are giving it the ID of 1 through the constants class. We do have the constructor method, but we are not using it here, and we don't really have a need for it right now. That's not to say we never have a need for that in a subsystem. It's just that in this case, we are not. We now have our personal methods that we create, and there's two things we want to do, right? We want to have our motor be able to run, and we want to have our motor be able to not run, right? We don't want it to just start and then keep going forever. So we're going to create two methods, right? First one we're going to call run motor. And for that, we are going to take the motor, and we're going to use the Rev Robotics set command, right? And we will say set to 0.5. And you may be wondering, what does 0.5 mean here? Well, in this case, it means 50% speed. This is on a spectrum of -1 to 1, where 0 means no motion at all, 1 means 100% power going one direction, and -1 means 100% power going the other direction. We're not trying to shake the entire robot right now, so we're just keeping it at 50%. So we have motor1.set 0.5. And then we have a stop command. As I said, we don't want it to spin forever. So we have something to stop it, and as I just explained, it's that -1 to 1 ratio. So by setting it to 0, we will stop all motion in the motor. We also have a periodic method here, and this we use for keeping data generally. Usually it's bad etiquette to have a print statement. You would want to put it on the shuffleboard or something, but if you really wanted, you could say something like motor output, and then you could add to this motor1.get, and now you will always be printing your speed. And that's not really necessary, so we are not going to put anything here, but that's the sort of thing you use this periodic class for. Moving on, once we create this motor system, we need to actually have a command to run it, right? We have these methods, but we need to put all of this into a command so that we can be running it from a controller in a set of commands. And really everything in WPILib is centered around commands. So let's take a look at what a command looks like. So you can see this is the overall setup, and we're beginning with setting up the subsystem, right? Now you can see we're actually drawing from constants with this motor subsystem. You can see that really you're only going to have one set of a subsystem in FRC, right? You rarely have multiple elevators on a robot or multiple shooters. And if you do, they're usually different in some way. And so we have this as a very static thing, right? We don't have multiple motor systems or any system. Again, we have a constructor, and not to say we never use the constructor, but we're just not using it here. You then have your initialize command, which can be useful. It is kind of, as the name sounds, when the command is initialized, when it starts up, it will run whatever you have within it. Then you have the execute command, and this is happening while the scheduler is running the command. Now, you might be asking what the scheduler is. The scheduler is kind of this thing that keeps tracks of all of the commands that are running in your project. And so you might have a few commands running at the same time, and every time the scheduler checks up on this command in particular, it's going to run this code. And you can see right here we have motor subsystem.run motor. And as we saw earlier, that sets the speed to 50%. And we also want to have something in case we end the command. And there is a difference between is finished and end. Is finished assumes there is a course of action. Say you take this command, let's say it was a sequential command, right? And it ran 3 different commands at the same time. When it finished the third, we could make it return true, and we could make stuff happen from there. Or we could be dealing with a different situation, which is that it is interrupted. And that's actually the case that we're going to be using here. And I'll get to that a bit more later, but essentially what we want to happen is when this command is interrupted, we will stop the motor, right? So when this command is being executed, we run motor, and that sets it to 50% speed. And when it is finished, we say stop, and we set it to 0% speed. Pretty simple. So now we have to actually take this command and make sure something can happen out of it. And we want the user or the driver to be able to create that input. So that's where we have the robot container class. So in our robot container, we first have to create the controller that we're using. Again, at Cavbotics, generally in the past, we have used the Xbox controller. And so for that, we use the command Xbox controller class. We name it, we set it up, we instantiate it, and we again have constants. We have a controller port, and that's 0. 0 is going to be the first port of the driver station in terms of controllers that you plug in. So when you first plug in a controller, it will typically be port 0. You could plug in another controller, and that would have port 1. And usually you're not plugging in any more than 2 controllers, but if you were, you can imagine if the first is 0 and the second is 1, the third would be 2, and so on. We then have to set the bindings. So we have this command, configure bindings, that we run in the constructor. And we then set up all of these controller bindings within this configure bindings command. So here you can see we have driver controller, right? That's the controller we use. We say .a. This refers to the A button. And then we have while true. So while true is one of a couple things you can use with triggers in WPILib. And we'll learn a bit more about triggers as the series goes on. But what's important is that we are using while true here when we do have another option for on true. If we were doing on true, we might have something that says, all right, we set the motor to 50% speed, and then we have a sequential thing that happens, right? Maybe we have a 1 second wait on that, and it continues, and then it stops. But in this case, we want it to be a direct input, right? While we're pressing A, the motor spins. While we're not pressing A, the motor won't spin. And so we have this while true, and then we say while true, new run motor. And what this is doing is it's creating that command that we just covered, the one that executes running the motor at 50% speed. And what's nice about the while true is when we stop pressing the button, it will not be a true anymore, right? It'll be a false. The button's not being pressed. And so it will detect that it's interrupted, it will end, and that will stop the motor from running. Very nice. So we now have this pretty much all figured out. There's just one last thing I want to cover, which is the robot.java class. You can see there are really just 3 important things here. And sometimes your robot.java class can get a bit more complicated, but it's very simple here. We are simply creating the robot container. We are instantiating it, and we are making sure the command scheduler is running. Remember I said earlier that command scheduler is keeping track of all the commands. And so we are running it in robot periodic. Robot periodic runs every 20 milliseconds just from the robot. And we also have a lot of these robot-centric commands, but I am not going to cover that because that's not the focus of this video. I also want to just address a lot of AP Computer Science students are probably used to using main.java, and I would like to clarify we never touch this when we are programming for FRC. This is not basic Java anymore. We are dealing with much more complex libraries, and so the closest you get to the start of the code is robot.java. And that's it. If you are set up to the Wi-Fi of your robot as is explained in the setup video, and you have this exact code or other functioning code that would work like it, then you should be able to simply turn on the robot, connect, and run this code. You would press Shift F5 to build and deploy the code. To make this kind of similar, it's like build is like compiling the code, deploy is like running the code, except, in this case, it's not running on your computer, it's deploying to a separate robot where you then enable on the robot. But yes, this is code that will make a motor spin, and this is the very base of how everything works in FRC, right? Everything we do is just really complex sets of motor spinning. So this is the video, and thank you for watching.